Hello, welcome to my first scopes related screencast. Today I'm going to talk about notation, particularly why is the notation of scopes the way it is, and what are the advantages and the drawbacks. So let's start by looking at some other notation to see where I was coming from. I was programming in C++ for the longest time, and C++ has a pretty, you could say, intricate notation that is at times particularly difficult to parse for a machine, not so difficult for an experienced programmer, but you can pretty much parse anything with experience. The general principle here is that except for basically you're looking at two languages that are interspersed, or two notations. Notation number A is the macro system, which is separated by new lines, and then the secondary system, which is the C++ notation, is designed in such a way that you could theoretically write everything in a single line and the machine would still be able to parse whatever you wrote. And this is pretty much inherited from C, so those are basically the same rules. And so that's C++. Scopes are done with these curly braces. Statements are separated by semicolons. They are not optional, you have to use them in every line. And you have to learn to do these braces real quick and also to format it in a way that makes sense. And there are so many different styles to formatting everything because it's completely left up to the user. You can either write the brace in the same line or you can put it in the next line. And we've been making a lot of jokes about the semi-religious wars that have erupted over these options. So I've always been thinking that if a language could nail down the way in which you would format your strings, that would end any discussion preemptively even. And so the second element that you see come up a lot is regular parentheses. The idea here is they are used for arguments and for parameter declaration. The idea here is that the declaration looks about the same as when it's used. There are commas to separate statements from each other. There's basically, you have like 3-4 different ways to separate stuff. You have the semicolons to separate statement, you have the commas to separate expressions, you have the braces to separate whole trees from tree branches from another, and then you have, of course, also infix tokens and special keywords, of which each one comes with its own rules, which take care of the rest. And it's elaborate, but also very expressive, and a lot of people use it. How is this? I copied this off the internet as an example, and this is I don't really understand how this is indented. Yeah, that's also a thing. Indentation can be whatever. You can indent statements in whatever way you see fit, and drive other people up the walls with your decisions. And that's C++. So how could we make such a notation a little bit more minimal while not hindering expression so much? And I think some of the best ideas come from script languages. There's, for example, Lua, which also follows the rule that everything could as well be layouted as a single line, but it has pretty advanced recognition of tokens when tokens begin and end. It has so you don't need semicolons to separate anything. They thought that braces would that the better use for braces would be to declare objects or tables, which are used a lot in this language, and functions. Even the parentheses are used in a way that you can, if you just have one argument and you don't need any comma separators and whatever, you can just leave them out like this, which is also makes for a few neat syntax sugar mechanisms that users can reuse for their own interfaces. And basically at this point it becomes evident that it would be useful for a language to give the user a way to invent new expressions or form of expressions, or like we say, domain-specific languages within the language that better help to describe whatever problem you're dealing with. And so that's Lua. And Python went even further and said, we are indenting everything anyway, so why not just do away with the begin and end tokens and just say that when an indentation ends, like here, we are automatically back in the parent scope, which I thought was a pretty cool idea and should be kept. And anyway, this language they have been trying to make so many things easy to read as well as easy to write. And I've been enjoying it tremendously. I mean, basically my C++ programming colleagues would, I think quite a few of them would rip out their hair in shock. And they are telling me that they don't like this indentation, this mode of indentation very much, but well, I like it. I've used Python for over 10 years now, and I particularly enjoy that you can do stuff like this, like you have a few statements which at some point become conditional, and then you can write like a new if branch on top of it and indent the whole block with just a press of the tab key. And if you should find at a later point that you don't need the conditional, you can just delete this line and hit Shift and Tab to put them back in the parent scope. And I always thought that is such a neat mechanism for typing quickly and refactoring. That was something that I wanted to keep. If you compare this to C++, you have tremendous amount of work to do to do the same job. So let's say we would like write the very same thing with statements that don't exist in just by the rules of C. You would have to do them like this. You would have to have these little separators here, which you may not forget. And if you frequently alternate between editing both languages, this can get pretty annoying quick, because you always write the semicolons in the wrong language. Interestingly, you could write them here and they would be okay. Python just understands what you were trying to do, and C says you have to play by my rules. I'm not going to make any exceptions. So if you want to put this in a conditional, you have to write an open brace here, which on a German keyboard is a bit annoying, as you have to press the key right of the space key and then 7 to get this character. And when you want to close it, you press the keys called Alt, GR, and 0 to close it. And that's something you have to do with your whole right hand. and then you can indent the block, which is just for visibility. It has no function. You could leave it like this as well, but then others would probably strangle you. So if you want to reverse the whole thing, you have to remove this character, and then you can remove this line, and then you can break it in. That's one step more, but if you count Levenstein distances for editing tasks and you want to make them count, then these small things add up over time. What's also nice is no, they don't actually have this. If you want to comment out a block in Python, you would, the quickest way to do it would be to either you have support in your editor for a shortcut that does this for you. I don't know which one. I bet they have one here, but I don't remember which one it was. Or you would put the whole thing in a multi-line string, something that C++ also didn't have until release 11. And here you would do a comment block like this. It's annoyingly, again, two different characters. So you have to remember that one. But at least they can be nested, which here isn't possible. So that's a way to comment blocks. In Lua, comments look like this, which is even worse than C++. And then that's it. So the next, so we have looked at C++, Lua, and Python. And Python is definitely the sleekest version of the whole affair, but they are also using extra tokens for stuff, and the parser is still sufficiently complex. So let's look at the language where the parser is not complex at all, which has the most minimal notation of all of them, which is, it's also one of the oldest languages. It's from the 60s. This is Scheme based on Lisp, which Scheme is like an even more minimal version of Lisp with better rules for scoping, as far as I know. And they do all scoping, all sub-expressions with parentheses, which makes, if you don't have the right editor for this, I mean, there are editors that color every brace in a different color, so they are pretty nice to distinguish, and you have these little indicators here that show you in what scope you are, so it's not entirely terrible, but I coded in this style for about a year, and at some point I was completely fed up with it. I mean, if you already do these indentations, you have these parentheses, closing parentheses, massing up at the end, and you think, okay, I know that they have to be there, and it's completely deterministic how many you have to put here. There's no surprise if you like do 7 indentations here, then you have to write 7 braces here. So why can't the parser just figure it out by himself? If I go to the next line, it should be pretty obvious that we are closing all these scopes if the next line is continuing here. So, but I nevertheless like the ambition of doing everything with as little parsing as possible. And another advantage of this whole system here is that basically you are writing in an interchange format. Yes, an interchange format like JSON, which is not a programming language or just a spin-off of a programming language that's really only used for describing data in form of objects with keys that are then bound to other objects, and these can contain numbers and strings, and entries are comma separated, And we are using the curly braces for scopes again, which is inherited from C. And that's JSON. And JSON is not really suited for programming. For example, there's no concept of symbols here, like something like this isn't really legal because there's no symbol named alignment. And JSON doesn't even... They argued, you have strings already, you don't need symbols. That's basically the same thing. I wish they had done this. That would have made things a little more interesting, but I mean, some stuff is just superfluous anyway, as we will see. So that's not perfect, but I like the whole idea of having interchange formats. And scheme itself is also an interchange format. You basically only have lists of lists and symbols, which look like these, and strings, which look like these, and of course numbers. And that's basically your interchange format. You have, you open a new list, the entries in the list are separated by spaces. You don't have to put commas or semicolons in between them. In fact, the semicolon is here used for commenting. You can just put everything next to each other. Also, scheme is also not indenting or line aware and treats everything like a single string. So it doesn't matter how you format these, that's basically always the same string. The same expression. So this is just describing a list with 3 symbols in the beginning and then some numbers and a string for good measure, and that's the thing. And you can put another list in it, and they have some special formatting tokens that are relevant to interpretation, which I'm not going to go into right now, but that's basically the idea. So I thought that at least that part is very neat about the language, that you have such a reduced format, which means that if you want to write tools that parse the language itself and analyze it and rewrite it in trivial ways, if you want to write that, that's very easy with this, because you just have basically like 5 object types, just one kind of hierarchy, and that means you save a lot of cases, special cases, corner cases, and so on, that you don't have to take care of. And when you write it back to disk, it's also sufficiently easy to format. If you look at C++, if you want to parse this, there are basically, I think nowadays everybody parses C++ with libclang, and it's a very elaborate, very complex system. And it's just not fun to rewrite C++ code programmatically in this way. So I think barely anyone does this. So, okay, so that's all of the other stuff. So now let's look at our language. So the core notation of scopes is basically a kind of JSON or scheme notation with some stuff thrown in from Python, so we have less typing work and less annoying parentheses to take care of. So let's imagine we would rewrite this JSON example in scopes. First thing we are going to do is get rid of all the parentheses, because we have indentation already, and that is all the information we are going to need. So I'm going to remove these, and these, and that's basically that would be the same file basically, where it's very clear which sections, how it's branching off, and which sections are nested in which other sections. And now you have to be sure that everything is formatted correctly, because then now it would be a syntax error, or alter the relationship of the individual elements. So what we can also get rid of are the commas, because we have the rule that an element on a single line is its own object or list in this case. We are going to once again do everything with lists, because if we want to describe a table, we could technically describe a table with lists. Like if you have a list like this, you could also make that colon acts as a separator for key and values, and you could have something like this, and that would also be a good descriptor for a key value table or an object. So the next thing we are going to do is we are going to treat the keys as symbols. We are going to support a special kind of string which isn't permitted to contain any spaces, which doesn't have to be put in quotes, and we call it a symbol. And then we can change the left part to look more like a declaration. And we are also going to remove the colons, because it's clear that the first element is always a declaration. It's always a keyword or a key. And that is basically that would already be, I think, valid scopes markup. Wouldn't be a valid program, but it would be parsable. So we could put the whole thing in a quote. If we wanted to do this as a program, we could do it as a quote. And then we could, let's see if that actually works. I'm not entirely sure. Yeah, and then we basically get the parsed structure back as a schemish lists, because under the hood the whole thing still supports a scheme format. Like you could put each of these individual lines in parentheses and then do this, and that would be basically the same thing. But ain't nobody got time for this, so we leave it out, and that's basically, I think that's a pretty clean format for describing data. And since code is also data, which was one of the driving insights of the design, we can also code like this. So we no longer need this one, or we don't necessarily need this one. And we can also do away with most of those. Basically, these come only into play if you want to write things a little more compact, but even then. And these we don't need at all. But I thought maybe you want to write some kind of domain-specific syntax that looks a bit more like C. So these, you can still do this, which is the same, and write multiple lists in the same line. But you can also put them in parentheses and put them like this next to each other. That's basically the same effect. And you can also still use curly braces for stuff, but the curly braces are put your expression in a special kind of list where you have to decide when you continue reading out the data what that actually means. So if you, for example, put the whole image thing in curly braces, then the whole expression is treated as a single list. Basically, the indentation notation is turned off as soon as you enter any kind of parentheses, and is treated as a single as a single list with a curly list header. So if you see this, then you know, a curly list was passed, and then it continues with the tokens that the list contains. So if you wanted to separate this the way it was separated before, you would have to now take care that everything was individually separated in the classical scheme way, like this, so that nesting makes sense again. But that's a bit lame. So what you can at least do is, for example, put everything in a single list and then use the semicolon as a list separator. Basically, the semicolon wraps the left side into a new list, and whatever is left on the right side is also wrapped. So if we do this, we get each of our entries neatly wrapped, and it almost looks like C. Let's tweak this a bit, make it look like this, and then basically you have something that looks like a C notation and parses like something you could read out easily in a program. So that's the introduction to scheme notation. I hope you found this at least mildly interesting, and see you soon.